Okay, team, this is the final constant acceleration formula. So the first question is, which constant acceleration formula is your current favorite? All right, thank you for sharing. The final formula is don't know, don't care. So take a gander at that formula and tell me what variable is missing in the above equation. Okay, hope you got that right. There is no time. So we already did don't know, don't care about acceleration along with the fire drill formula. This is the relationship when you want to get rid of time. This is the way I learned it, but many people prefer to take that minus v naught squared and put it over on the other side so that you don't have this minus sign floating around. Okay, so it is final velocity squared equals initial velocity squared plus 2 times the acceleration times x minus x naught. All right, you will get that equation. The one thing you want to be careful about is when you're solving for v squared or v naught squared, you're going to take the square root of things, and the solutions can be either positive or negative, and it's your job to know, oh, it's going down or left, so that must be negative. So look out for that. All right, so you might think, well, why do we need that? We got position function, we got velocity function, we got all kinds of stuff. To me, the examples that makes the most sense is you are flying a jet airplane. You are coming in for a landing, an emergency landing in an airport that is smaller than you usually land in, and you don't really care how long it is going to take the plane in terms of time, how long it's going to take the plane to stop. What you want to make sure is that this runway length is long enough. All right, so you would go back and you would say, I know how fast I'm going, my V naught. I know I better bring that plane to a stop, that's 0. I know in general how quickly my plane can decelerate, and I want to know what is this delta x. What is the length of the runway I need? That's my quick calculation. All right, so I think that's the best example. The other example is, I understand that sometimes if you are a lawyer who wants to prove fault, that when someone else had a car crash, you can go back to this and you can say, I measured the skid marks. That's the distance the car traveled. I know on average how quickly car tires and brakes can make a car decelerate. I know my V final isn't 0 because this car crashed into something else, but I can maybe estimate from the damage what that V final was, the speed of impact, and then work backwards and say, how fast was that car going when it started to brake and crash into the car, into the second car. All right, so those are two real-world examples of when you might use it, and now we're just going to do kind of a, physics is never boring, but we're going to do another example. So you have a ball rolling up an incline, but the environment's pulling it down the incline, and I don't know why this is out of order, but it was going up the incline with initial speed of 5. So the first thing we're going to do is draw a position versus time graph. Acceleration being negative means it is a concave down parabola. The initial speed of 5 means the IROC at this point is 5. And I think that's it. So it's going to go up the incline and head back down. And the question is, find the maximum height. We want to know what this x value is. Now clearly, if you were going to make a graph, you want to know what time that happens as well. But maybe this goofy story is, you send the frictionless cart up the incline, and we want to know what's the max height. I better have an incline long enough or it's going to fall off the incline. Okay, so we're pretending like we don't care what time that happened, so we're going to say v squared equals v naught squared plus 2a x minus x naught. Anywhere to the left of the vertex, the slope is positive, you're headed up. Anywhere to the right of the vertex, the slope is negative, you're headed down. So that means at that infinitesimal instant at the vertex, the speed is 0. So that is our final speed for the time interval we care about. Clearly not the final speed, but we're looking at this certain interval. Okay, v naught squared was 5. So I'm going to square that. My acceleration is minus 1.4. You really want to be careful about the minus signs. And we decided x naught was 0. So we get 0 equals 25 minus 2.8 x. I'm going to subtract 25 from both sides. And then I'm going to divide both sides by negative 2.8. And you get, if this were minus 2.5, that'd be 10 even. So we're a little shy of that. 8.925 meters. So that is your max height. If all you want to know is, hey, how long a ramp do I need to get out of the physics lab, that's the length of the ramp you need. If you are going to make a graph, you're going to care about time. But where we're going, now that we know all of the equations, there's lots of different ways to check your work, and so that's a nice way to become a flexible problem solver where you can check your work. Okay, final equation. Hope it made sense. See you in class.